Okay, so we are going to start with rational expressions today. And rational expression is just a ratio of two polynomials, meaning it's a fraction with x's in the top and the bottom. So what's important for us to start with on these first few is to remember that you cannot divide by 0. So you have to make sure that that denominator is not equal to 0. So they're going to ask you on the first set of problems for domain restrictions. And that just means what number cannot be put in the place of x. And you figure it out by figuring out what number x needs to be in order for the denominator to be 0. So we want the denominator to not be 0. So we have to figure out when that would happen, and then we know what we can't use. So they take the denominator, set it equal to 0, and solve that little equation that I just made. We get x is negative 5. So if I want this denominator to equal 0, that happens when x is negative 5. So all I have to do to give the excluded values is put a does not equal in here, and I'm saying x cannot equal negative 5. All right, so number 2. If you take x squared minus 36 and set it equal to 0 and solve, you're going to add 36. I don't know what that is trailing behind everything that I like to read. So you have x squared is equal to 36. To get rid of a square, you're going to take the square root of both sides of your equation. And remember, if you're the one that introduces a square root to the problem, you have to account for the fact that 6 times 6 is 36, and negative 6 times negative 6 is 36. So then we're just saying that x cannot be 6 or negative 6. All right, so number 3, we're going to take this denominator, figure out when it's 0. Well, when you have a quadratic equal to 0, first of all, I don't know why they put this in the middle, put this in this lesson, because you haven't learned to solve a quadratic yet in this class, but you have in a previous class. So to solve a quadratic, the best way is to factor, not necessarily the best way, but in this case, the best way is. So we're going to factor this, and I think we're going to get negative 7 and positive 2. So x minus 7, x plus 2. Then you have what's called the zero product property that says that if I multiply those and get 0, then one of those things has to be 0. So we figure out that x is 7 and x is negative 2. And those are the two times where I'm going to get 0 in this denominator, which is going to cause a problem because you can't divide by 0. All right, so if you're at home today, quarantined or whatever, and you don't understand this, we will spend a couple of days at solving quadratics, which is what you just did on number 2 and number 3 to get those restrictions. And it's not going to be on your next test, so don't lose any sleep over not understanding what we just did here. It'll be okay. It'll work itself out later. Okay, so we are going to now just talk about simplifying rational expressions. So the main idea with this lesson, and we're going to take 2 days to do it, we're going to learn to simplify, multiply, and divide rational expressions today. And then tomorrow we will do add and subtract those rational expressions. All right, so a rational expression is simplified when its numerator and denominator have no common factors other than a 1 or a negative 1. So things are simplified when you can't divide both pieces by the same thing anymore. All right, so to simplify rational expressions, you're going to factor the numerator and the denominator and then divide off common factors. Now, big mistake that I see is people will look at this problem and be like, ooh, there's an x, there's an x, ooh, there's a 3, there's a 3, and cancel those out. And you can't cancel when there's addition or subtraction. You have to have multiplication before you can cancel. You've got to take whole things. So I cannot knock this 3 off just because there's one down here, because it's being added to something, and that's important because the order of operation says I've got to add up here and add down here and then divide. So I can't take pieces of things that are being added. I have to take the entire thing. All right, so step 1, factor the numerator and the denominator, anything that'll factor. Alright, so looking at just this numerator, both of these have an x in them, and we can take out an x squared, and that'll leave me with x plus 3. The denominator is not going to factor, but you'll notice at this point that this x plus 3 and this x plus 3, those are identical, and those are whole pieces. I'm not taking just the 3 or just the x, I'm taking the whole x plus 3, so that's legal. And all that leaves me is an x squared, so we're done. Alright, so number 5, if we factor the numerator, we get x plus 1, x minus 1, because it's a difference of squares. And again, I know that little box is there following me around. I have no idea why. The denominator, you have a trinomial, so we're going to guess and check. We need x and x, we need 1 and 1, and everybody's positive, so everybody's positive. Alright, so now that you factored, do you see that there's an x plus 1 on top and an x plus 1 on bottom? Well, you can divide those off and they equal 1 because they're identical. Something divided by itself is 1. And that's going to leave us with x minus 1 over x plus 1. Alright, so they give you a single rational expression, one fraction, then you factor the top, factor the bottom, divide off things that look the same from top to bottom, write down what's left. That is all. Alright, if they give you more than one rational expression, like if you look at number 6 and number 7 on the screen, then it's either going to be multiplication or division. Alright, so you're going to, first of all, factor all of the numerators and denominators. Divide out your common factors, making sure that you only cancel out numerators with denominators. Multiply your remaining factors, and you're done. But it's very important that you remember that division means multiply by the reciprocal. So your first step of its division is to handle that idea. Alright, so that was drastic. Let me see if I can get it to go better. Number 6. X plus 3 will not factor, so write it down. X squared minus 4 is the difference of squares, so you can do x plus 2, x minus 2. X squared minus x minus 6 is guess and check, and it should work out to x minus 3, x plus 2. X squared plus 6x plus 9, you're going to guess and check, and it works out to x plus 3, x plus 3. Alright, so now we're looking. Let's see. I noticed that this guy matches that guy. And this one matches that one. Everything else looks like this. These look similar, but their signs are not the same. So you cancel out all you can cancel out. The numerator still has an x minus 3. The denominator has an x minus 2 and an x plus 3. I don't need you to actually multiply that out. I'm okay with you leaving it just like this. Alright, number 7, you have division. So the first step is to remember that you are going to multiply by the reciprocal. Or they taught you keep, change, flip in elementary school. So make it multiplication, flip the second fraction over. Right, now we can factor everything. So this guy is going to be x minus 1, x minus 1. For this, all I can do is take out an x, so I have x squared plus 1 left. For this one, we can take out a 3, so we have x squared plus 1. And then here, we're going to guess and check, and x plus 2, x minus 1. Alright, so now it's a matter of go through and see what matches from top to bottom. So this and this are the same, so they divide off. And this x minus 1 can cancel this x minus 1. I believe that's it. So in the numerator, we have a 3 and an x minus 1. And in our denominators, we have an x and an x plus 2. And that's going to be our answer. Alright, one more. Again, it's division, so first step is rewrite it as a multiplication problem. If you can factor as you rewrite it, I'm okay with that. Just be careful and make sure that you really do flip this one over. Alright, so if it's division, the first step is change it to a multiplication problem. So change it to multiply and the reciprocal. So flip that second guy over. Alright, so now it's a matter of factoring. So x squared minus 5 is minus 25 is a difference of squares. So it's x plus 5, x minus 5. 2x minus 2, we can take a GCF of 2 out. Alright, both of these guys are trinomials, so we're going to guess and check for both of them. I know I'm factoring quickly, but that's not the point of this lesson. If you need help with factoring, though, please let me know. Alright, so I think x plus 5, x minus 1, and then here x plus 5, x plus 5. Alright, so then we see what is it that we can divide off. So I believe there is an x plus 5 in the top and the bottom, and then also this bottom with the one over here, and then your x minus 1. So my numerator has an x minus 5, and my denominator just has a 2. Alright, so that's simplifying and multiplying and dividing. Please let me know if you have questions, and again, if you're still struggling with factoring, let me know that too, so we can try to get a handle on it.